This is the last practice exercise which covers the review on the proving portion. After this, we are now going to proceed with the real meat of the third grading period, which is the first real meat rather, which is on a triangle similarity. But first, let's talk about this one. We are still going to prove something here, but unlike the previous um, practice exercise, which is only concerned on the congruence of two triangles, we are now asked if we could prove that the sides BL, let's use it, BL and EN are congruent, given the situations that NO and LO and BO and EO are actually congruent. Do not say automatically SAS postulate. Some of you will say, yes, they are congruent because of SAS postulate. Take note that LB and BL rather and EN are not given. Okay, so how do we deal with this? When we talk about proving parts only, okay, because BL, side BL and side EN are just parts of these two triangles. If we're talking about proving them whether they're congruent or not, we could actually still pass through triangle congruence. Because once we have proven that the two triangles here are congruent, then we can assume that the rest of the corresponding parts of these two triangles are also congruent using the concept of CPCTC. CPCTC stands for corresponding parts of congruent triangles are also congruent. To do that, let us again copy the given here. Copy this one. Okay, and then copy the item that we would like to prove here and probably place it here at the bottom. Okay, so to have that, this is actually one, and the reason one is always given. All right, so we are already given with that. Let me erase this. This is the item that we'd like to prove. Okay, okay, I'm given and that NO and LO are congruent. I already marked it here, as well as for BO and EO are given. So we already have two sides. Okay. So you have S and then S. Take note that if we talk about triangle congruence, we may use SAS, ASA, and then SSS. Okay. Any of these three, when achieved in our proof, will determine that the two triangles are congruent. But ASA, because we have only one side and two angles here, but two sides already given, therefore ASA is not anymore possible here. So it's either between SAS and SSS. Okay. But to do that, take note that the last side, okay, is the side that we are trying to prove. Okay, so just a reminder, we may not use SSS here, but rather SAS. Right? Because the third side is what we're trying to prove. We cannot say SSS and then prove the third side that supports the SSS, circular referencing. So we can try to look for other relationships here. So SES is the possible item here. The included angle is this angle and the angle here. So we need to show that they are also congruent to come up with SAS. And we can establish that using, so yeah, let's say angle BOL is congruent to angle EON in what reason? Okay, they're actually, you know this already, probably some of you are more familiar with this. The reason behind this is that they're actually vertical angles. The reason is vertical angle theorem, which tells us that when two angles are vertical angles, they are actually congruent. Or in shorter form, vertical angle theorem tells us that vertical angles are congruent. Now that we have established that, we have the last value for A. Okay? But then again, as I mentioned in the previous video, you might want to check that out. We don't have SSA postulate. What we do have is SAS. And it is also achieved because A here is actually an included angle between two sides. So we can now say that triangle BOL is now congruent to triangle EON. And the reason behind this is again not SSA because we don't have SSA triangle congruence postulate. What we do have is SAS, and again, A is an included angle of the two sides, so that satisfies the SAS triangle congruence postulate. Okay, now that we have established that the two triangles are congruent, we can now show this as our last statement. And again, once that we have proven that the two triangles are congruent, it follows then that all corresponding parts are also congruent. And the reason for that is simply, let me increase the size, CPCTC. CPCTC, which stands for congruent parts of which stands for corresponding parts of congruent triangles are also congruent. This is the complete proof for this practice exercise. Again, we started with the given. We looked at, since we are trying to prove that the last side is congruent, so we may pass through triangle congruence, and we do have two sides ready. We look for the included angle, and we did. Then we have achieved congruence of the two triangles. Then the CPCTC. Thank you very much for watching. The next few videos will now cover triangle similarities after learning or reviewing the ratio and proportion to column proof and this concept, triangle congruence. See you soon. Goodbye.